Welcome everybody. Pause the video and read the question carefully. Question says, you have an equation that is in equilibrium. We have B mole of hydrogen iodide were put into a sealed vessel at pressure P. At equilibrium for sure. X mole of hydrogen iodide has dissociated. So we just do the same procedure as we did for the equilibrium equations. So at T equals 0, at which we don't have a products, we started with B moles of HI, and for sure we have 0 for H2 and 0 for I2. Now at time equilibrium, for sure since we have hydrogen iodide that is a reactant, there is a decrease in its concentration, so the number of moles will decrease. So we can say B minus, but minus what? We're supposed to say minus 2x, but the question says the number of moles that are lost is equal to x. Okay. On the other hand, we have I2 and H2, but what should I write? Should I put x for them? No. X here is represented for the 2HI, but we need to represent only one, which means that the value for H2 and I2 will be x over 2, and here x over 2. Because the examiner himself supposed that the 2x is equal to x, then the half of x is equal x over 2 and x over 2. Now we have the number of moles at equilibrium. The question is asking me to calculate the Kp. And we remember that the Kp has a law in which you have the partial pressure of I2 over the partial pressure of I2 multiplied by the partial pressure of H2 over the partial pressure of Hi squared. But we don't have partial pressures. We have to remember something, that if you want to calculate the partial pressure for these gases, you should have the mole fraction. So if you remember the mole fraction, which is the number of moles at equilibrium for a specific material over the total number of moles. So you know what's the meaning of the mole fraction. And we multiply it by the P total in here, which is given in here. It's P. So how can I calculate the mole fraction for the whole things in here, like I2, H2, and Hi? For I2, the mole fraction, it's the same as the mole fraction for H2 because, like they're 1-to-1 ratio, and they almost have the same number of moles. We can say the moles of H2 or I2 is equal to x over 2, which is the, for each one here apart. And then we have to take the summation of all things in here. We can say this is B minus x, the summation of reactants, plus x over 2 for I2 plus x over 2 for H2. And if you make simplifying, x2 plus x2 equals x, and you have minus x, they will cancel out each other here, and then you will end up with x over 2b. Then the mole fraction for I2 and H2 is equal to x over 2b. Perfect. I want to calculate the mole fraction for Hi. We can say b minus x over, these are the number of moles at equilibrium, over the summation of all of these guys. You can say b minus x plus x over 2 plus x over 2. And you will end up with b minus x over, those are cancelled out, over b. So the Hi has a mole of b minus x over b. Perfect. Now we have to do something else. All right. So the Kp is equal to the partial pressure for I2 multiplied by the partial pressure of H2 over Hi. And we can say that the partial pressure for I2 is equal to the mole fraction, which is x over 2b. This is for I, multiplied by b. And then we multiply it with the partial pressure for H2, which equals to the mole fraction of H2, which is 2b. And then we have to multiply by p. And then we divide it over the mole fraction for PHI squared is equal to b minus x squared over b squared, right, multiplied by b squared. Okay, now we have to cancel these out. The p's are gone. Now we have x squared over 4b squared over b minus x squared over b squared. So at that point, how can I cancel out these? We can cancel the p's together in here, and you will end up with x squared over 4b minus x squared. And at that point, the answer is D.